particular section. Busy waiting. Busy waiting means we are continuously waiting to occupy the processor or occupying the resource. Then that state is called as a busy waiting. So here in this example, I want to occupy this position. Actually, these two people are there. These two people is wants to occupy this location. So they're continually checking the information whether this location is free or not. If this location is free, then any one of them is enter into the corresponding location. If the location is not available, then continuously they are in waiting state. Then that situation is called as a busy waiting. Next one is, what is semaphore? A semaphore is a protected variable or abstract data type that is used to lock the resource being used. So one of the simple example. So if you're taking any railway station, if the railway station contains only single track, so how many trains can be placed on the single track? Only one train can be occupied the single track. For example, two trains is want to occupy the same location. Then we have to identify which train is the first came to the track. Then that track can occupy. Then that track can be occupied by the corresponding train. But what about the remaining train? The remaining train should be in the waiting state. So here, how much amount of time the second train will wait means whenever the current train is departed from the corresponding track up to that time, the corresponding second train should be in the waiting state. So this is the best example for semaphore. It means at a time only one can perform the operation. So if one train is on the track, the second train should be in the waiting state. That is he has to wait for some time. So after the train is depart from the track, the second train is moves onto the same track. So the value of the semaphore indicates the status of a common resource. There are two different types of semaphores are there. The first one is a binary semaphore. The second one is a counting semaphore. What is a binary semaphore? Binary means it contains two values, either 0 or 1. So the help of binary semaphore is used to implement mutual exclusion and synchronize a concurrent process. Mutually exclusive means at a time only one can perform the operation, the remaining should be in the waiting state. So just see this example. So here process P1, process P2 wants to occupy this location. That means shared resource. So process P1 is the first enter into the shared resource. The process P2 should be in the waiting state. Whenever the process P1 is complete a task and remove from the shared resource, then the turn goes to process P2 and enter into the corresponding location and perform the operation. So this is the concept of a binary semaphore. What kind of operations are possible on a semaphore? Actually, there are two kinds of operations we have to perform. The first one is wait, the second one is signal. Actually, how the coin contains two phases. If the head is visible, then automatically tail will not be visible. In the same fashion, if you see the waiting, then internally it can perform a signal. If you see in the signal, the waiting will be in the background. Okay, so these are the two operations can be performed on a semaphore. Next one is mutex. Mutex means mutually exclusive. So mutual exclusive means it is a lock that we set before using a shared resource and release after using it. Okay, so when the lock is set, no other thread can access the locked region of code. That means, for example, same as binary semaphore. So see this one, thread 1, thread 2. These are two threads want to occupy this location. Okay, this shared resource. So which thread is the first acquire the lock? That means which thread is getting the lock first? That thread will be entered into the shared resource. After that, after perform the operation, the thread is release the corresponding lock. So automatically thread 2 will take the lock from thread 1 and enter into the shared resource and can perform the operation. So this is the concept of mutex. Next one, what is a deadlock? Deadlock means suppose a process requests some resources. If the resources are not available at the time, the process enters into a waiting state. A waiting process may never again change the state because the resources they have requested are held by some other waiting process. This situation is called as deadlock. But the definition is very lengthy, but the main logic is very simple. Okay, just see this diagram. So two process P1, process P2, process are there, two resources are there. First of all, resource 1 is assigned to process P1, there is no problem. Resource R2 is assigned to process P2, here also no problem. After some time, process P1 wants resource R2. At this time, resource R2 is not available. Now process P1 moves on to waiting state. Okay, here also no problem. After some amount of time, process P2 is also wants resource R1, but resource R1 is not available. Then automatically process P2 moves on to waiting state. Then automatically process P1, process P2, these are two processes is goes on to the waiting state. That means you did not identify at what time they are um, releasing the data. So this situation is called as a deadlock situation. Okay, so what are necessary conditions for a deadlock? Means there are four conditions are there. The first one is a mutual exclusion, second one is a hold and wait, third one is no preemption, the fourth one is circular wait. Okay, these are the necessary conditions for deadlock. Next one is it possible to have a deadlock involving only one process? Actually no. So deadlock with one process is not possible. When it will possible means more than one process and number of resources are there, all the process should goes on to waiting state, then that will be called as a deadlock. But whenever one process is presented, there is no chance to occur a deadlock. Now, how you have to identify the deadlock in the system? So with the help of a resource allocation graph, RAG, with the help of resource allocation graph, we can identify the deadlock in the system. Yes, you have to see this diagram. This is called as a graph, resource allocation graph. Which resource is allocated to which process and which process is take the resources. All these things should be identified with the help of the resource allocation graph. Next one is what are the solutions to recover from a deadlock? That means how you have to recover means there are two solutions are there. The first one is a process termination. The second one is a resource preemption. Process termination means so in this diagram, the process P1 is a terminate the resource. That means the process P1 is a stop the operation here. Then automatically you have to remove the deadlock. For example, for resource R1 is removed, automatically deadlock will be removed. So this is the way to recover from a deadlock. Okay. Next one is what is Banker's algorithm? Banker's algorithm is also be called as a deadlock avoidance method. So the name is called as Bankers. Why the name called as Bankers means, for example, what is the purpose of bank? The purpose of bank is maintain some customers and some needs of the customers can be managed by this bank, right? So with the help of the bank, we have to share the resources or we have to create some resources. For example, 5 customers are there in a bank. If the first customer is created 1 lakh amount of money into the bank, the second customer and third customer and fourth customer wants some loan amount. For example, second customer wants 25,000, the third customer wants 35,000, the fourth customer wants 50,000. So total amount is 60 plus 50, 1 lakh 10,000. But the bank which contains only 1 lakh. So automatically the bank can identify which is having the minimum loan amount. So first of all, they have to clear the loan amount. Okay. So first of all, that amount will be given to the corresponding loan persons. Okay, so with the so we have to meet some requirements. So automatically you have to assign some particular kind of money to the corresponding customer. So after some specific time period, the loan customer is created the amount to the corresponding bank. That means clear the loan amount. So automatically you have to manage all the customers in the bank. The same fashion in the case of system also, we have to identify what are the available resources and what is the maximum capacity of the resources and what is the requested resources. So you have to keep track of all these things, then we have to avoid the deadlock in our system. Next one is what is starvation in operating system? Starvation is nothing but indefinite amount of blocking of resources or processes. That means the process or the resources are moves on to indefinite blocking, then that will be called as a starvation. So what is aging in operating system? Aging is a technique used to avoid the starvation in the resource scheduling system. That means the drawback of the starvation can be removed with the help of this aging technique. Next one is what is cache memory? The purpose of memory is store some kind of information. There are different types of memories are there. Cache memory, main memory, secondary memory, auxiliary memory. There are different types of things are there. So out of these, so cache memory is the fastest memory. Why the cache memory is called as fastest memory means what the frequently used data, the frequently used information, that information is stored into the cache memory. The size of the cache memory is also very less when compared to RAM and when compared to hard disk. Okay, so if the CPU wants some information, first of all, that information is first checked in the cache memory. If the data is available here, then move on to CPU and execute data. If the data is not available inside the cache memory, now the cache memory takes the data from the main memory and main memory to cache memory and cache memory to CPU. So this is the purpose of cache memory. Okay, one of the best example, Google search engine. For example, if you're typing the Google search engine, what is operating system? So automatically displays some number of links, right? So why we will get the data within a fraction of seconds means, so what the information we are repeatedly using, that repeated information is stored in one memory. That memory is called as cache memory. So within the less amount of time, we have to get the data and we can perform the operation. Next one is virtual memory. This is the very, very important one. Virtual memory is a future of a operating system. Without having a virtual memory, no system is existed. So here, separation of user logical memory from physical memory. Virtual memory is called as logical memory. Logical memory means which will not be visible. Physical memory means which will be existed. The best example of physical memory is RAM. Okay, so what the best example for virtual memory means, for example, my application size is 5 GB, my RAM system RAM capacity is 4 GB. Now, is it possible to execute the 5 GB application in 4 GB RAM? Actually, it is not possible. But with the help of the virtual memory concept, we have to execute the 5 GB application data inside the 4 GB RAM. How it is possible means, first it takes the 4 GB of amount of data into the RAM, the remaining 1 GB of amount of data is from virtual memory. So in this way, the virtual memory